This is the screencast for section 3.4, example 1. We are going to look at some properties of logarithmic functions. The properties that we're going to look at right now are the product rule, the quotient rule, and the power rule. Now, in the first two proofs here, we are going to look at why the product rule and quotient rule work, and then you'll be able to infer why the power rule also works. Now, just a little tip to help you remember what the product rule, quotient rule, and power rule, how they convert from one side of the equal sign to the other. You are always converting one log into two logs, or if you're going backwards, two logs into one log, except for the power rule, which you're changing an exponent to a coefficient. So maybe that'll help you in your restating those rules process. Example 1, prove that the product rule of logarithms, proving the product rule of logarithms. So we're going to prove that the log base b of r times s equals the log base b of r plus the log base b of s. So we've got that over here as our product rule listed out. Now, if I remember right, logs find exponents. So technically, log base b of r is an exponent and log base b of s is an exponent. And so really I'm adding two exponents together, and if I think back to my Algebra 2 and sometimes even Algebra 1 rules, when I add exponents it means I'm multiplying by the same base. Interesting. Okay, and then I've got a multiplication over here. So I know that's going to come to play in this proof. First, I don't like log base b of r or log base b of x, so I'm going to call x log base b of r and y log base b of s. So I'm going to let those equal each other. Now, to change those into exponential, let's see, I've got b to the x equals r and b to the y equals s. So I changed from logarithmic form into exponential form. And the reason I did that is because I understand exponential properties better than I understand log properties. So let's change these logs into exponential form. Now, if I take r times s, r is b to the x, and s is b to the y. So r times s is b to the x times b to the y. And remember what we said, when we are multiplying by the same base, we add the exponents. So really this right-hand side is b to the x plus y. Okay, so now what? How about let's take the log base b of both sides. Now I have a property that says that the right-hand side, since the base of my log is b and the base of my exponent is b, I can simplify that to be x plus y. Now on the left side, I just have log base b of r times s. Now on the right side, I have x plus y. Well, if I look back to what I defined x and y to be, log base b of r times s equals x, which was log base b of r, plus y, which was log base b of s. Therefore, I have completed my proof. And basically, my strategy in my proof was to write these complicated log expressions as x and y, change them to exponential. I know how to work with exponentials. So I changed them to exponentials and then manipulated them into getting the shape of the other side, log base b of r times s. And then substituting back in at the end what I originally called x and y. So I substituted x and y to make my life a little bit easier, which I know this doesn't seem very easy, but hopefully after we practice the now try problem, you'll get the hang of this. The now try problem is number 37. Prove the quotient rule of logarithms. Well, the quotient rule says that the log base b of r over s equals the log base b of r minus the log base b of s. So right away I'm thinking, okay, subtraction and division, that's very similar to my exponential properties. If I have x to the fifth divided by x to the third, it's really x squared because I would subtract their exponents. So I'm going to use these same x and y expressions to write in, and I'm going to take r divided by s after they've been converted to exponential form. I would get r is b to the x and s is b to the y. So I'm using the same setup over here for this property as well. They're on the same page, so I don't have to restate them. Now, what would I do? Well, b to the x divided by b to the y is x minus y, or b to the x minus y. So I'm going to take r over s, that stays the same. But on the right, I have b to the x minus y. Now I have x and y in an exponential as exponents, so I'm going to take the log base b of both sides. So on the left, I get log base b of r over s, and on the right, the base of my log and the base of my exponent are the same, so x minus y is the result. Now I have defined x to be log base b of r and y to be log base b of s, so I can substitute those back in at the end. So x is log base b of r minus log base b of s, which was y. So again, my strategy was, instead of working with logarithm properties, because I don't know any of those, I changed it to exponential so that I could work with those properties and then substituted it back in at the end.